Welcome to Spring LIB.
This is the answer to chapter problem number 12 from the Smith Organic Chemistry textbook. And this problem is asking us to draw the results, the products of two anionic polymerizations. And so remember, this relates to epoxy, and the polymer making bonds that we form are going to be carbon-oxygen bonds rather than carbon-carbon bonds. And so we should start by considering the epoxide that we're given. And so here is our monomer. This is the epoxide that we have for A. And we should think about what that's going to look like once it's opened. And from there, we can begin to get the answer. So the way that a lot of these answers look for this type of polymerization is you just draw the central unit once in brackets with this N notation, so the lowercase n, and that basically just indicates that it's repeating as many times as you'd like. And so having drawn that, we then need to think about what our opened epoxide is going to look like. And so in this case, it's going to look like, oops, where'd that line go? In this case, it's going to look like this. And so be a bond there, will be a bond there. And so this central unit here is our opened epoxide. And again, it's in the N brackets, and so this means that it repeats, indefinitely, N number of times. And then the only other thing we need to draw is what the two ends of this polymer are going to look like. And so each of the ends of this polymer is just going to be another opened epoxide. But an opened epoxide with another hydroxy on it, because remember, hydroxy is going to open the epoxide to begin with to sort of kick this whole process off, and so our end pieces are going to have hydroxy functionalities on them. And so there's our answer for A, and then we can look at B. And again, I will just redraw the epoxide so that we can sort of see what we're working with. So in this case, we have an epoxide coming off of a six-membered ring. So there we go. Put arrows in. Okay, so this is going to be actually, exactly the same as A was. In terms of how the polymer forms, the only real difference is going to be the side chains, because in this case, the side chains are going to be these cyclohexane rings. And so we can do just as we did last time, and start by making the central unit here. There's our six-membered ring. And so that is going to be our core. So that repeats N number of times. And then we just need to consider the end pieces. And just like last time, the end pieces are going to have hydroxys on them. So there we go. There's one. Hydroxy on the other end piece as well. And then, of course, another six-membered ring here. Okay, and so that's B. And again, remember this question dealt with anionic polymerization. And so remember, the way to solve these is to look at the epoxide, think about what the epoxide is going to look like once it's opened, draw the central core in the brackets with the end to show that it repeats indefinitely, and then just draw your end pieces with hydroxy groups. And so that's the answer to chapter 31, problem number 12.